Yeah, I'll start with the toolbox in general. So I hope you all can see my screen. So this talk is about. I'll do it very quickly. So there are two parts in this talk. This half an hour is divided in two parts. In the first part, I will speak, and in the second part, we have invited some students from VIT, and they will share their experience. Can you please confirm if the VIT team is there?
I'll check.
Yeah. So first of all, I would like to tell you what is a toolbox. First of all, okay. So toolbox can be thought of. Toolbox actually is a very general terminology, not necessarily a Scilab toolbox, but any software can have a toolbox. So why? What is the purpose? So essentially, toolbox is a collection of programs, right? And these collection of these set of programs have a very specific task to do. For example, for FOT was specific to solving optimization problems, not image processing problems, right? And these operations, these specific operations, they may not be already available in the native tool, right? For example, some nonlinear programming or something was not available in Scilab, which the FOT is not providing. So that could be one case, or there could be something already available in Scilab, but not optimally implemented, or has some limited features. So a toolbox can solve all those problems, right? Now, what is the benefit of using a toolbox or having a toolbox essentially? So one benefit, there are so many actually. I'm just listed a few benefits. First is the base package, that is the base Scilab. We don't have to make any changes to the base Scilab, right? Remember FOT or GUI toolbox, whatever. Any toolbox you load inside Scilab, it is not going to change the code, the base code of Scilab. It is going to remain the same, right? Also, Scilab, if you don't have a toolbox, suppose toolbox is embedded inside the Scilab and Scilab.org releases these capabilities as this base software package itself, the size of Scilab is going to go, increase like anything, right? So it doesn't make sense. Then, because these things are loadable and unloadable, these are very safe and very temporary upgradation of the native tool. So, for example, when I was talking about FOT, I made Scilab capable of handling optimization problems, right? But the moment I was done, I can unload the toolbox and I can go back to my old Scilab. Can be platform independent in cases where the toolbox is purely written in Scilab. You don't care on which platform do you run this toolbox, because as long as Scilab runs, the toolbox will also run. And very important point is that toolboxes enable power of C, Fortran, Java, such utilities. For example, FOT itself, the CLP, OSI, IPOP, some of the libraries are even written in Fortran. We have to, while compilation, we have to enable G Fortran, right? So those legacy codes, those tried and tested code in older languages, they all are available now. So Scilab is the toolbox are available in Scilab in two places. One is Atoms. Atoms basically is a one-stop portal for all Scilab toolboxes, right? So I'll go here. I'll click on the Atoms Scilab.org. So this is that Atoms page, and you can see there is a huge category of toolboxes, and they all have counts also, how many toolboxes per category. And you can go ahead and explore all of these. People from various domains can benefit from Scilab, not just mathematicians or engineers. There are many other domains also. All categorized properly. Then they also have versions. For example, if I go to FOT, I can search for FOT here, and I'll find FOSSEE optimization toolbox. Here it is. As you can see, there are versions also, right? There are almost 1, 2, 3, 4, 5, 6, 7, 8, 9 versions of FOT, right from the first version. So all these are available. I'm not saying you should go and run an older version, but what I'm saying is all the history is also available. So if some version doesn't work for your particular case, you can go back to an older version. Suppose sometimes what happens is that we release a version, but then it has some more bugs introduced. Rather than solving problems, we end up complicating problems. So you can go back to the older version of this. If you scroll down, you can see, first of all, it has some first cut description, short description about this toolbox, and you can read this. It also has some instructions, additional instructions to use this toolbox if you need to satisfy some dependencies. It has features also. It has a change log also. Change log will give you, this is a habit of most programmers, elegant programmers, that they maintain change logs. Change logs help the users understand how the toolbox has been evolving and what are the various things that have been addressed since the last version, right? And then if you come here, you will always find at least two things you have to download. One is the source code, and second is a binary. The binary could be available for both Windows and Linux or any one of them, depending on what the authors have decided to release. Okay, so now in case of FOT, you have both Windows and Linux. For some versions of FOT, we also have Mac versions. So this latest version has only for Windows and Linux. We are in the process of compiling it for Mac as well. You can come ahead and volunteer if you can spare some time to help us with the Mac system. Then forums are also there. So here in Atoms page, you also have a comment section, right? Forums as in comment section. You can always log in, register and log in, and you can, whatever comment you put here is going to be directly communicated to the authors of this toolbox page. Okay. Demo, I don't know if I can show a demo. So what I can do is I can go back to this Scilab console, and demo means basically this was the way in which you download the toolbox manually and use it, or you can go to Scilab and run it from the Atoms modules manager. You can see this icon here, module manager Atoms. If you click on this icon, it will open the main categories Atoms module manager window, and whatever categories you saw on the web page here earlier, here these categories, these all are available. Okay, you can choose from any category and you can run. You can suppose I want to install this toolbox. This page will open and I will have an install button. You can simply install. But after the installation, you have to restart Scilab in order to load the toolbox. And then every time you start Scilab, it will load automatically. You don't have to worry about it. FOSSEE Scilab toolboxes. So as sir mentioned, a few toolboxes: communication systems, signal processing. I'll just list them down. So I'm highlighting four important toolboxes that we have spent most of our time, devoted most of our time. And these are these four. There are many more also that we are working in parallel, and they will be out soon. To talk about FOSSEE optimization toolbox, sir mentioned CoinOR, right? So CoinOR is this. I'll just open the website. So CoinOR is, as Professor Mahajan also mentioned. So it's an, it's a operational research, portal for various libraries are there, which you can use. They provide basically solvers, to solve various optimization problems of various types. And so these are state of art and globally accepted and tested and used heavily in the industry and in the research. So, and fortunately, this is all open source, right? So FOT is making use of CoinOR, to the extent possible, and basically we are serving this facility to the general public via Scilab. FOT again, I showed you the admins page. GitHub again, because we are all open source people, we will never hide the source code for anything. Everything will always be there in the public domain. So, including the source code of the toolboxes. So this is the official page for FOSSEE, GitHub page for FOSSEE, account for FOSSEE. And under this, you will find many projects, which are maintained on this GitHub account. FOSSEE optimization toolbox happens to be one of them. So this is the source code. You can always go here and download the source code. And the reason why we want to put it on public GitHub is because we want people like you to contribute. Right? You would have, there are some students also here. If you are good in C++, if you understand some basic theories, there are some basic skills that are required to build a toolbox. If you are good enough, you can always come here and help us improve it. For example, here you can see issues. There are some issues which are raised, right? Some unit test issues, some Fortran issues, something like that. You can always pick up an issue and solve it, and it will really help us improve the toolbox. We can also raise some issues so that we come to know that something has to be fixed. Scilab-Octave, I'll talk about the software architecture using the GitHub page. This is the FOSSEE Scilab-Octave Toolbox GitHub page, and so this was done with the help of Professor Kumar Appaya. So essentially, like we said, we always want FOSS tools to work together, right? So Octave seems to also have huge database of packages. They call it packages. We call it toolboxes. Scilab people call it toolboxes. They call it packages. It's essentially the same thing. And they have some very good signal processing, communications, image processing, etc. They have some good packages. So instead of switching to entirely to Octave or rewriting the code in Scilab, rather than doing these two things, what we thought about is, why don't we just simply communicate with Octave via Scilab, right? So that has been bundled into a toolbox, which we call it as FOSSEE Scilab-Octave Toolbox. And I'd like to show you the entire communication, the entire connection between Scilab and Octave is handled by this one C++ file, just one. This one C++ file was enough for us to communicate from Scilab to Octave. Of course, there are some limitations, but for most problems, it provided as a good bridge between Scilab and Octave. What else do I have? Again, because a good amount of work was done and it was ready to be shipped, we published this toolbox on Atoms, and here it is. I will show it to you. Here is the FOSSEE Scilab-Octave Toolbox. It also shows, by the way, how many downloads have happened, right? So for this particular version, which is 0.2, about more than 1,000 downloads have happened all over the world. For both versions combined, there are about 2,500 plus downloads. It also mentions for what OS it has been released. Right now, it is only for Linux, and then files. Our FOSSEE Scilab page. Here is this page, scilab.in/FOSSEE-Scilab-Toolbox. Here you will find information about all the toolboxes. So you see optimization. Yeah, if I click here, I will get this option of examples. If you go to examples, you will see this linear optimization. These are all examples which we have coded, and you can always go there. We even have references like from which book we have taken, etc. And then the problem, like we saw, word problem, something like this. And then there is a formulation done here, and then converted to metrics, and then solved. Right? We also have the expected output. This is what you should get. So that was for FOT. Similarly, we will have it for other toolboxes also. We can go ahead and explore. Scilab-Octave toolbox is here. I have some basic instructions. That's it. Toolbox Hackathon, Scilab Toolbox Hackathon, we did this for the first time. And the idea was how can we speed up the process of toolbox development, and how can we have more number of toolboxes in a less number of time, in less number of efforts, and less number of investments. So we have a huge database of good students who are very good in programming, who can literally solve the problem for us in no time. Something that we will take months to fix, they could just do it in a day or two. So we wanted to make use of such a manpower that is available in our country. And Hackathon is an initiative to tap into that segment, and make use of it. And there is a win-win situation. So we get some good toolboxes from students, and students also benefit because they get to work on real problems, and they get publicity also because their names get displayed. They earn also. There is a prize money involved. So they get something as a reward. They get certificates. All those things. So let me just go to this page. So this happened in the month of May, between May and June in 2020. This was during the ongoing pandemic, right? So while the pandemic put a break on many things in the world, we actually geared up. We actually accelerated our activities, and this was the right time for us to reach out people, because everybody was sitting at home, and mostly they have very less thing to do, and most of the time was getting wasted. Colleges were shut, offices were also shut. So students had a lot of time to do all this things, and we made use of that time. And this hackathon, I'll see the slides. Yeah, so the idea behind this hackathon was to connect Scilab to an already established open source software, right? So, for example, we gave them a list to begin with, okay, to the participants. So these are various topics that we identified, first of all: numerical libraries, software products, mathematical software, web-based solutions, deep learning, differential equations, whatever. So I'll just open one example. The list of statistical software. So there is a huge list of software which does a particular which is made for a particular domain, and some of them are open source, some of them may not be open source, I don't know, but whatever is available and open source, we ask them to choose that established software, open source software, use those software and connect it with Scilab. That was the objective of the hackathon, right? And they were free to choose anything that they like, whatever domain that they are good at, whatever tool that they might have used in the past, whatever. So they choose one software, already established software, and try to connect that software with Scilab. I would also like to mention that VIT Chennai actually helped us a lot. They are also our FOSSEE partners, and they provided us with an example toolbox. They connected their team, the students of VIT, under the supervision of Subalakshmi ma'am. You would have heard her speak on the first day. So she, along with her students, they came up with a Python interface, Scilab Python interface toolbox, and it was an excellent toolbox. We were very surprised that our students are very capable of doing all these things. We don't know until we ask them to do it, right? So they came up with it, in a very less time, and it was given out to the participants as a reference toolbox. Like, this is what we are expecting, and this is how you connect two things, right? It was a reference toolbox, and we also had some tutorial on that. Like how do you go about using that toolbox? How is it made? So we had a VIT support during that hackathon. There were about 700 proposals. Okay, so we had a proposal stage where people proposed which software they want to connect to, and of these 700, there were 42 shortlisted. You look at the number, 700 to 42. Why? Because we wanted quality things, and we wanted people who understood the philosophy and the idea behind it, and the technicalities that are involved. We make sure they understood that, because it was not an easy task. It was a very challenging task. And out of the 42, we selected top 12 teams, and from the top 12 teams, there were 9 winners. Okay, I would like to show the winners. Here they are. You see, so I was talking about this already established open source software, right? So the first five teams are here. Champions, we call them champions, and essentially they successfully connected Point Cloud Library, Armadillo, GraphViz, GNU Scientific Library, and Pandas. So you see the amount of power here that was given to Scilab in just one hackathon. Then we had consolation prize winners. They did also well. One team, they did Keras. Blender is an animation tool. R Studio. And OpenEdX was a special project where they utilized Scilab inside an LMS environment. So this was the outcome of the hackathon. It was very, very successful. It was beyond our expectations, and we are really excited. And in the similar ways, we will keep on adding more toolboxes to Scilab. You can also participate in the future events. Similarly, I think I'm at the end of my talk. Yeah. I would request VIT team, if they are there, you can start presenting.
Yes, sir. Good afternoon, everyone. Myself, Mahesh, from Scilab Python Toolbox development team, and we would like to share our experience. I would like to start with Akash.
Thank you, Mahesh. Good afternoon to the audience member. I'm Akash Aaron of VIT Chennai, joined by my teammates who developed the Python Toolbox. which integrates Python with Scilab. This toolbox was made under the guidance of FOSSEE team of IIT Bombay in the summer of 2020. This toolbox was later released in Scilab Atoms and was also used in one of the spoken tutorials on Scilab Toolbox development. Furthermore, the toolbox was provided to the participants of Scilab Toolbox Development Hackathon, conducted by FOSSEE, as it was mentioned by Mr. Rupak. Each of us had a very specific role, like Jishnu was the lead developer, Adrian worked on porting the Scilab Toolbox into Linux, Adityan worked on SymPy library, Diksha was our lead tester, I was working on the help file generation and code snippets for the users to understand, and Mahesh worked on the testing of various libraries that can be imported through our toolbox Python. The development of Python toolbox as a whole definitely ranks among the most exciting projects that we had worked on. It was an educational journey which was sweetened by the recognition and support we had gotten from FOSSEE team and VIT Chennai. The scope of the project was magnanimous compared to the project we had worked on before and required our complete dedication to succeed. I would like to acknowledge our faculty guide, Dr. T. Subulakshmi, who was the person who introduced to us the scope of open source software and guided us through the various difficulties that we had faced while developing this toolbox. The Scilab Toolbox development, along with its ups and downs, was an educational and exciting mission. And I'm saying this on behalf of all my teammates that we are looking forward to contribute further towards the global good with our abilities in the future. Back to you, Mahesh.
Sorry to
Now we
interrupt. You have any presentation? Do you want to share your screen?
No, sir. Means yes, sir. For me, you can enable it.
You want to show something? Okay, let me see.
Now we have Diksha.
Good evening. So my team overcame many challenges during the development and testing phases, which led to us making a better toolbox. At the beginning, when we were asked to extend this, we found it difficult to find the API documentation of PIMs and other support options. But after deep analysis, we proceeded to create a new toolbox. We faced many difficulties, like porting, and the new toolbox requires Python 3.8.3 to be installed in the system to function properly, but we added a new module such that it's automatically detected and installed if it's not present. We also encountered problems during lab migration and plotting graphs using matplotlib library. But after overcoming everything, I would say that this is an arduous journey and it has been fruitful because we've learned so much more than just developing the toolbox. We're more informed about Scilab, Python, modules like NumPy, sklearn, and networking. I would also like to recommend that while opportunities like these are presented to students, they should take it up as a challenge and not worry about the fact that they don't have previous experience or knowledge about the field. Most of us did not know about toolbox development or about Scilab either. And in any project like this, what you learn is exponentially more than what you think you're going to learn. Mahesh?
Yes, now we have Adrian.
Good afternoon, everyone. So this project that we have worked on, the development of this toolbox was an exercise in, teamwork, yes, attention to detail, as well as learning many new development tools and methods as well. So
I'm sorry, I think Adrian is facing some internet issues. Actually, what Adrian was trying to convey was that the scope of the project, the various functions that we had implemented, and the difficulties that we faced while doing this, but the difficulties as such were an extraordinary learning opportunity. Like when we imported various functionalities, like when we had a function that can run a Python script in Scilab and give the output in Scilab. While doing this, we faced various difficulties. Each one of us were working in a very specific role, and the collaboration among us, along with the help of FOSSEE team, really made these difficulties easy to overcome. And therefore, we would like to thank the FOSSEE team first of all and Subulakshmi ma'am for this, as well as recommend to people to take up such an opportunity if presented to them.
Yes, now there were also Jishnu and Adrian, but because of some circumstances, they are not present. So I would like to share their videos.
I remember the night when we got a call from Professor Subulakshmi stating that we were offered an opportunity to work under the guidance of FOSSEE team of IIT and develop a toolbox for Scilab and contribute towards the open source community. We all knew that this was a once in a lifetime opportunity and we would be making a huge mistake if we let it pass. Ma'am told us that if we decide to accept this, then we will have to see it to the end. and cannot step down, and assured us that we will be rewarded if the program becomes a success. We were asked to treat this no less than a professional task and carry ourselves suitably. We were told that regular meetings will be conducted, which would be organized by ma'am herself, where she will track the progress of the project, and also asked us to be prepared for meetings which will be organized by IIT anytime and they may ask for progress report or may have questions regarding the project. This would be when we could also interact with them and ask some questions which we had regarding the project. We were asked to take into consideration all these points and then give a final decision. And as you can see, we all agreed to all the conditions and took up the opportunity and started working on it. In the starting stages of the project, we never thought that we would be creating a toolbox for Scilab. Our objective was to identify the shortcomings and errors of the already existing two toolboxes, namely PIMS and SciPy, and fix those errors. In the weekly meetings conducted by Python team, everyone was asked to present a detailed report on our findings of the past weeks. If it was an error report, it should contain the code that caused the error, description of the error as to what it meant, and a possible reason behind the same. If it was a test report, then the details of the function that was tested to be specified, and the extent of testing, the expected and observed result also needed to be specified in the project. During the analysis of the already existing toolbox, the official documentation was hard to find and making the functions which were implemented in toolbox much harder to understand and making the error correction a little bit unsafe task. Hence, it was decided that it will be a better choice to create a new toolbox altogether. Once the objective was updated from improving the current existing toolboxes to creating a new toolbox, everyone was assigned the task to research and successfully create a small and simple toolbox that could be further improved by others when they are all working together. This is when Jishnu found out that Scilab had a sample toolbox which is included along with Scilab that gives the developer an idea on how to create and build a toolbox for Scilab. Using the sample toolbox and the shortcomings of the existing toolboxes in mind as a reference, we started the development of Python. Throughout the process, we had the constant support from faculties of both colleges. We had regular meetings with them where we updated the progress of development to them, and they helped us overcome any hurdles if we faced any. In addition to developing the toolbox, we were also asked to document the process and create a spoken tutorial script for the same. To help us understand how to create a spoken tutorial, we were provided with detailed documentation about the same, which had all the instructions and important points that needed to be taken care of while making a script, which made the process very much easier. They also provided with a sample script so that we could get an idea about the format and other minor details that needed to be followed. The spoken tutorial script was reviewed in detail and frequently by the faculty in charge and gave us valuable feedback specifying us the regions where we could improve on the script, and in the end it was successfully published along with the toolbox. Everyone in the team had enough work to do and everyone contributed to the project as a whole. Every person in the team had dedicated roles in the development process and they performed their roles flawlessly. It was a wonderful experience working alongside such bright and under such supportive and brilliant faculties, and would like an opportunity like this again. Thank you.
Hello everyone, I'm Jishnu of VIT Chennai. I worked as a lead developer in the Python toolbox with Scilab. More specifically, I wrote the code for the functionalities of the toolbox. When we first started working on this project after being given the opportunity, we weren't even thinking of creating a separate toolbox. We started off the work by analyzing two existing toolboxes for an older version of Scilab. They both serve the same purpose of enabling the use of Python modules in Scilab. After a top-level analysis, we were given the option to either dive deeper into the source code of those two toolboxes and figure out what exactly is causing the issue in the latest version of Scilab, or search for workarounds and look for ways to recreate the functionalities instead of porting the existing libraries. I decided to explore the latter option and came across a newer API for building toolboxes in Scilab. I tried to recreate some of the very basic implementations of Python into Scilab using this newer API, and that was the starting step of this toolbox. From there, we covered one feature after the other and went way beyond what we initially planned by adding almost a complete integration of Python into Scilab, surpassing the functionalities provided by the existing deprecated libraries. We received help from Professor Subbulakshmi of VIT and Rupak sir from FOSSEE team at each step of this project. Every single feature that was implemented, tested, and documented were done under their guidance. Once the functionalities were implemented, we were given the opportunity to show our work to the world by means of a spoken tutorial video. I wrote an extensive documentation of the entire source code and along with the other team members helped write the script for the spoken tutorial video, which was then illustrated and voiced by the FOSSEE team and published on their website. Along with the spoken tutorial video, our toolbox source and documentation were also made available as a reference for the Scilab Hackathon that was conducted by IIT during that time. And I feel quite proud in saying that the winning team of the hackathon were using the source code of the Python in their entry. After the toolbox is completed, tested, and polished, the documentation of the functions of the toolbox were written by our team, and then the toolbox is published onto the Atoms repository of Scilab. The toolbox was then ported to Linux by our team, which was also added to the Atoms repository. Working on this project has been a really good and new experience for me. It felt so much more than just another project due to the professional environment that was followed by our team. Everyone worked with each other in every aspect of the toolbox. This toolbox would not have been complete if not for the cooperation, teamwork, and effort put in by every single member of the team. And again, all of this would not have been possible without the help from VIT and FOSSEE team from IIT. I would like to thank Subbalakshmi ma'am for choosing us for the work and giving us the opportunity to work on such a project, and all of the FOSSEE team for guiding us with every aspect of this toolbox. Thank you.
And finally, I would like to share my words. Our team's effort came to light when the toolbox was approved and added to Scilab's official Atmos repository. And moreover, a spoken tutorial was also created which explained the using and the working of this toolbox. It was noted that 73 workshops from 73 different colleges around the world conducted for the same, which included around 2,200 participants and still counting. After the successful completion of the development and the testing process, we received a certificate of appreciation from IIT Bombay and VIT, which marked the completion of our 2 months of internship. The certificate was considered equivalent for a 2-credit university course. And lastly, no duty is more urgent than that of returning of thanks. So on the behalf of my team, I would like to thank Dr. Subbalakshmi ma'am for introducing us to this wonderful opportunity, Dr. Kanan sir, Rupak sir, Vinita ma'am, and all of the rest FOSSEE team members for their support and encouragement. Thank you.
Thank you so much. Yeah, you had a great time developing the toolbox. Thank you for the feedback.
Subbalakshmi ma'am is there if she wants to.
Yeah, Subbalakshmi ma'am, if you want.
No, actually, Vinita, students are talked enough. So I think let it be.
Okay,
Yeah.
Okay, ma'am. Thank you so much. So yeah, it was not possible without your guidance, ma'am. So everything what you have learned, I hope you use it in future and stay connected with us. Thank you.